The dynamic vapour sorption method is actually a gravimetric method. That is a technique which involves measuring the change in the sample mass. In the DVS method, we expose the sample of interest, a powder, fibre, or indeed film, to a different humidity. So by changing the humidity, we look at the way the sample mass changes with time for a particular humidity. It turns out when you expose a material to water vapour is very strongly attracted to virtually all materials. This is why we see a change in sample mass. The reason that water vapour is so attracted to materials is that water is chemically wanting to be in a liquid form. Because it's a condensable vapour, it will effectively interact with any solid state material you might have, be it organic, inorganic or biological. When we do a DVS experiment, we will discover that water vapour that we expose a sample to can be adsorbed on the surface, it can be absorbed in the bulk, or it can actually condense in pores in the material. So there are three distinct locations where we might find water molecules in a material after we've done a DVS experiment. Because of those three different environments, we can actually obtain three different types of data. We can obtain information about the surface of a material, such as the surface area. We can obtain information about the porosity, such as the pore size distribution. And we can also find information about the solubility, the way in which water dissolves inside a solid state material. And those three classes of information sets are often unique to the DVS method, making it a very powerful research method. If we look in the modern analytical laboratory, we will find very few, indeed probably no instruments that look at the way a material behaves as a function of humidity or the relative humidity in the air. So DVS in many ways has a unique role in the laboratory. Other techniques you might find in a laboratory which are relevant would be loss on drying, as well as Carl-Fisher titrations. But both techniques are relatively artificial because they expose a sample to a very strong chemical environment or heat it. And neither of the techniques will tell you how much moisture you have in a material as a function of the actual humidity, which of course is what the DVS method does. So in many ways, the DVS is a unique technique in many laboratories. So although the DVS technique is now over 20 years old, the DVS technique continues to advance, to become more sophisticated, and to provide richer sets of data in the characterization of materials. SMS developed the use of organic vapours, the use of Raman and near-IR, and we continue to expand the opportunities for doing DVS experiments. So some of the newer developments that we're working on more recently include the use of gas adsorption rather than vapour adsorption, the use of more than one gas or vapour molecule in the study, and also the ability to do multiple samples at the same time, simultaneous experiments. These are all new advances in the area of DVS, and they will show even more opportunity for researchers to use the DVS technique in their everyday research work. The DVS Adventure is a water-only adsorption analyzer, and it is the most advanced water adsorption analyzer in the marketplace. Not only can it operate over a wide temperature range, from 5 to 85 degrees, it can preheat the samples from 300 degrees down to minus 50 degrees. It can also use, in addition, both video, Raman and near-IR to obtain even more information about samples. So this new product, the Adventure, is easily the most advanced water adsorption analyzer in the current industrial and academic market. Historically, the pharmaceutical industry has been the industry that has gained the most from using DVS data. And DVS data will be found in hundreds of scientific articles and patents around pharmaceutical materials. Though we still work very closely with the pharmaceutical industry, in the future, other market sectors will become increasingly important. Biopharmaceuticals, even polymers and foods, building materials, will become increasingly important areas as people begin to appreciate the unique and important research insight that DVS data can give you in your research problems.